All right, Chapter 6 talks about energy during chemical changes, and we talk about different kinds of energy, but mostly we're going to focus on heat. And there is a lot of homework for this and a lot of definitions, so make sure you take time to figure out all these definitions so you will know what the words mean when you're reading the homework problems and the quiz and test problems. On the top of page 6.2, I've given a space that I labeled My Equations. There's quite a few calculations of different types in this chapter. I suggest that as we're going through, each time I introduce an equation, you flip back and you write them down here. When you do that, it gives you practice. You write it down and then all your equations will be in one place. When you're doing the homework, just flip to that page and say, okay, which of these equations is going to help me? Then when you're staying up all night before the test, pulling an all-nighter, cramming for the test, you've only got one page to look at for equations. They'll all be written in the same spot. But if you've learned them through practice, you won't be doing that, but they'll still be all in one spot. So as we introduce energy, we talk about the SI unit of energy, which is the joule, and this is spelled Joule. This is for James Joule, the person that this is named for. It's not jewel like emeralds and rubies and diamonds and sapphires, not that kind of jewel. And it is defined as 1 joule is equal to the energy a 2 kilogram object has when it's moving at a speed of 1 meter per second. And this comes down from a kinetic energy definition. Kinetic energy, energy of motion, can be calculated. It's equal to 1/2 the mass measured in kilograms times the velocity in meters per second squared. So the kinetic energy, 1 joule, is equal to, 1/2 times the mass in kilograms times the velocity, meters per second squared. So the unit, the joule, is equal to kilogram meter squared per second squared. So that's where the unit comes from. And knowing the derivation of this will make it helpful when you're trying to get the units to balance sometimes or get the units to cancel. And definition of a joule, 4.184 joules on the metric system is equivalent to 1 calorie that you might be more familiar with in the English system. The calorie is the amount of water, the amount of energy it takes to heat 1 gram of water up 1 degree C. When you think of calories, you think of the number of calories in your candy bar or whatever. That's not this calorie. Those are kilocalories. They are 1,000 of these guys. So the dietetic calorie is a kilocalorie, or the dietitians call them a big calorie. Big because there's 1,000 of them. I don't know why they call it big, but that's what they say. So this is how we use this. What's the kinetic energy of a 3.5 kilogram ball rolling at a speed of 24 meters per second? Well, we know the algebraic equation. We slap the numbers in and solve. Kinetic energy is 1/2 mass times velocity squared. So that's equal to 1/2 times our mass, 3.50 kilograms, times 24.0 meters per second, the quantity squared. So multiplying across, I get 1.75 kilograms times 576 meters squared per second squared, and that's equal to 1,010 kilogram meters squared per second squared, or 1,010 joules, and that would be equal to 1.01 kilojoules because that last zero is not significant. So we can calculate kinetic energy just by plugging in the numbers. Because this is an algebraic equation, we can solve for any variable. We look at this and we have mass, velocity, and energy. We have 3 variables. If we know 2 of them, we can solve for the missing variable. So I have one for you to try on the next page. Let's go ahead and just have you work this at your seats.